All right, hello everyone. Again, I'm Kathy Zip, Associate Editor of Solar Power World, and I'd like to welcome you to today's webinar, Understanding Clean Energy Standards. Before we begin, I'd just like to go over a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com, and the webinar will also be emailed to all attendees. Secondly, there will be a question and answer session at the end of the presentation. You may submit your questions at any time throughout the webinar by typing them into the GoToMeeting panel that's on your right. And lastly, we realize that not everyone who would have liked to attend the webinar could, so we encourage everyone to tweet about key topics and discuss any takeaways using the hashtag CESwebinar. So at this time, I'd like to introduce our presenters. Today we have Justin Barnes, and he is the Senior Policy Analyst at DesireUSA.org. And we also have CJ Calavito. He is Commercial Engineering Manager at Standard Solar. So thank you both again for being here with us today. And Justin is actually going to be our first presenter. As Senior Policy Analyst at the North Carolina Solar Center, he's worked on the database of state incentives for renewables and efficiency, which is also known as Desire, since 2007. In addition to performing general updating and maintenance of Desire, Justin also manages the site's quantitative RPS research and the North Carolina Solar Center's activities under the Solar American Communities Outreach Partnership. His research interests include innovative financing mechanisms, solar renewable energy certificate markets, and net metering in states with retail electric choice. Justin received a Bachelor of Science in Geography from the University of Oklahoma and a Master's in Environmental Policy from Michigan Technological University, where his research focused on wind energy siting policies and the commercialization of cellulosic ethanol. Today he's going to share some of his expertise with us. So Justin, go ahead and take it away whenever you're ready.
Okay, folks. So as Kathy mentioned, I'm a Senior Policy Analyst at the North Carolina Solar Center, where I spend a lot of my time working on the Desire database of state incentives for renewables and efficiency projects. Although the headline here says clean energy standards, I guess that could have different meanings to different people. And when I talk about clean energy standards, what I'm really going to be talking about are renewable energy standards or renewable portfolio standards. And for this audience, specifically those standards that have mechanisms that directly support solar energy. In other words, kind of separate it out of the general renewables tier and make it a special case. So basically, just to start with, here's what we have in terms of the State of the Union in terms of RPS policies or renewable energy standards. You've got 29 states plus D.C. and Puerto Rico that have a mandatory RPS, as well as a few states that have something a little bit more flimsy, a voluntary target. And just to kind of set the stage, the real, importance of this particular policy mechanism is that it signals a commitment towards long-term support of renewables. In other words, it provides a long-term market signal, and that's really what's needed in order to build an industry. Now, in the context of solar, a lot of states have realized that if you're going to support solar through an RPS, you need to do something special. And so rather than having solar compete with a lot of, say, more established resources such as wind, such as hydro, such as biomass, if you're going to support solar through an RPS, you really need to make kind of a special dispensation and separate it out a little bit so that it's only competing with itself or other kind of solar or distributed generation resources. And that's what a lot of states have done. 16 states at last count, plus DC, have an RPS with a specific solar or distributed generation provision. And those states that have those specific provisions that support solar or distributed generation have tended to be the ones that have the most solar development. Now, there are a few exceptions to this, and I've included those in black boxes. So you've got California, which is probably the most notable exception to that. The California market is a little bit unique in that they've made their long-term commitment in other ways through programs like the California Solar Initiative, through very progressive net metering, a variety of other different ways, and so that still provides the kind of long-term support that's necessary in the market certainty, but it just hasn't been done through an RPS or a solar-specific RPS. Hawaii is a little bit of a different animal in the sense that it has very high electricity prices, so solar is inherently more cost competitive in Hawaii than it is in most other states. And then finally Florida, where we have seen a fairly substantial amount of development in the past. It's been kind of characterized by a few fairly major incentive programs and a few fairly large installations. And so while if you look at a chart that shows installed capacity in Florida, it comes up pretty high. There really is no long-term consistent mechanism for supporting solar in Florida. And as a consequence, in the next few years, or at least under the current policy environment, I guess the prospects don't look quite as good as they do in some of these other states that have established that long-term mechanism. And so, when we talk about solar RPSs, in a lot of ways, when we think about what it means for developers or system owners on the ground, we're talking about SRECs. An SREC stands for Solar Renewable Energy Certificate, and basically it represents proof that 1 megawatt-hour of electricity or energy has been generated from a qualifying resource within a state. And it can be separated from the underlying energy or electricity and then traded separately from that underlying energy or electricity. And most states rely on RECs or SRECs to determine compliance under their standards, and as a consequence, there is a demand for SRECs from these obligated entities, and that means that an SREC has value. Now, the tricky thing about SRECs in many cases is that most states define them in a very customized way. So one SREC does not necessarily another SREC. A New Jersey SREC doesn't have the same set of attributes or value that a Pennsylvania SREC has. And ultimately that comes down to variations in the state level policy and how they design their system. But I guess the point to drive home is that SRECs represent potential value because there is demand created by that state RPS program that has a solar specific provision. Now, in terms of those state policy variations, there are certainly quite a few. Every state that develops an RPS or a solar RPS kind of does it in a very customized way. I've identified a few of the different variations that you're going to find, and attempted to kind of sort out what that might mean for you thinking about a project on the ground. So first, there is a pretty significant distinction between electricity markets that remain regulated, where utilities are providing bundled electricity service, versus restructured markets where consumers have electric choice. And in terms of, say, the obligated entity in regulated markets, you have your investor-owned utilities, these regulated utilities that have the energy obligation, the full energy obligation under the RPS. Whereas in restructured electricity markets, this tends to be put on the energy suppliers, and those could be competitive energy suppliers, the ones that go out and seek retail customers to provide them with energy service. It could also include IOUs that provide, or investor-owned utilities or other utilities that provide default service to customers that choose not to go and get a competitive energy supplier. And in some cases, the IOU has an obligation for its default load. In other cases, that is put on the energy supplier that's providing energy to serve that default load. Now, the regulated versus restructured question also tends to determine, to some extent, the type of transactions you see in terms of SRECs. So in a state like Colorado or a state like Arizona, where the utilities are fully regulated, what you often have, particularly for small systems, are these fairly standardized incentive programs that go through a Public Utilities Commission approval process. And it might be the utility will pay residential customers X dollars per megawatt hour, or X dollars per SREC over 10 years of the system, or 15 years of energy production from the system. versus an open trading market that exists in a state like Pennsylvania, where you as a generator or ultimately are required to go out and kind of pick your way through everything and find your own buyer for the SRECs that you happen to own. And usually, at the small scale level, this would typically be done through a broker or an aggregator. Although, some large scale systems could potentially sell directly to obligated, what are usually called load serving entities. Then, in kind of between that, is models that focus on a certain amount of open trading, but also with regulation. And that regulation is typically provided in order to get at a little more price certainty over the long term. And what you find with that are, regulations requiring long-term contracts, which is something that has existed in the past in New Jersey, or what we've got in Massachusetts right now, which is this kind of clearinghouse auction where SRECs that say a generator is not able to market themselves can potentially be included in an auction and ultimately get kind of a basement price for that SREC that provides a little bit more, if not perfect, pricing certainty. There are also some pretty significant variations in terms of resource eligibility. That could be, geographic eligibility, whether a state limits qualifying resources to those that are located in the state. Within the region, potentially requires delivery through the bulk transmission system of electricity for larger scale systems. It can take the form of resource definitions, whether the state RPS is PV only, which happens in a couple cases, whether it's just distributed generation, which of course could include other technologies beyond solar, whether it includes solar water heating, whether it's solar electric only, which potentially includes solar thermal electric, which is a possibility in the Southwest, and then sometimes specific size limits or other effective limitations on system size. So an example of a specific size limit would be in Massachusetts, where qualifying systems are limited to 6 megawatts. An example of an effective limitation could be, a requirement that systems be located behind the meter, or that they be connected to the distribution grid rather than the bulk interstate electricity transmission grid. Finally, obviously, we have some variation in terms of the targets and timelines. So you've got, some fairly modest targets, like in North Carolina, some more ambitious targets, like Delaware, some very ambitious targets, like what you've got in New Jersey, which would probably equate to 6 to 7% of retail electricity sales. And then variations in target formulation, megawatts, megawatt hours, or percentage, and the actual schedule of increase, which in most states kind of ramps up gradually in percentage terms over time. There are some states that have multiple years that have the same percentage requirement, or Massachusetts, which has a mechanism by which they can adjust what the standard is in any given year based on market conditions. So I tend to get this question a lot because folks have a hard time looking at that percentage standard and saying, well, what exactly does that mean for me? And what they ultimately tend to want is, what's SREC demand going to be in a given state at a given time? And potentially, what does that translate to in terms of installed capacity needed to serve that demand? So, there are some pretty basic equations that you can use to find out these values. Percentage standard times the forecast retail sales that are covered under the RPS. And if you want to get to megawatts, you take that SREC demand, divide it by an annual production estimate per megawatt, and you can get a pretty good ballpark idea of how many megawatts are going to be in demand in a specific state at a given time. Of course, in practice, this is a little bit trickier. There are a number of complicating factors. Actually arriving at a long-term retail sales forecast, figuring out what percentage to allocate to solar for a DG carve-out, or for solar thermal electric versus PV in states where that's a practical reality. Figuring out how to account for multi-year SREC lifetimes and carryovers, accounting for multipliers that might exist. And then the relevance, increasingly the relevance of cost containment provisions, and whether you could potentially exceed a ratepayer impact cap, and whether that might result in a suspension of the standard for a year or two, or I guess even potentially a backtracking of the standard. And of course, potentially, there is always the potential for somewhat unpredictable policy change, which perhaps is more likely as we go forward, because with greater stringency and standards comes, greater potential costs, whether those costs are, real or perceived. And on kind of the other side of that equation is, figuring out what supply is. And, supply is basically, if you want to, pare it down to its most basic, is, what's on the ground that qualifies currently versus what's in the pipeline that you can reasonably think will actually, come online. The tricky part about this is, one, just it's relatively, in most cases, you can figure out what's on the ground with a decent amount of research. Figuring out the pipeline of projects and what might come online, within the next 2 years or within the next 3 years or 5 years is a little more difficult. And it's made more complicated by the fact that, while SREC demand under an RPS is state-specific, in reality, the supply may not be, because there are plenty of states, or a few states anyway, that do allow out-of-state projects to qualify. Whether that's Pennsylvania with a regional requirement, whether it's Ohio that allows neighboring states, whether it's North Carolina that allows a certain amount of unbundled out-of-state recs, whether it's Missouri that allows basically the whole standard to be met with out-of-state recs. Instead of trying to figure out what the supply is in a single state, you're forced to go much further and try and figure out what it is in 5 different states or 6 different states or 13 different states. And that complicates things pretty substantially. And also, one of the things that's important to think about is that if you don't have an in-state SREC market, the broader the eligibility of those various markets that you might be able to participate in, the lower the SREC prices are typically going to be. So, in a state like Missouri, where basically anything and everything is eligible throughout the U.S., yeah, everybody's eligible, and that's great. But as a consequence, SREC prices are so low that they're basically providing a home for SRECs that can't go any other place, and consequently, you end up having fairly low prices. Certainly, not what you would expect to get in a state like New Jersey or Massachusetts, where the qualification requirements are much more stringent. So, since we don't have a ton of time, I've elected to kind of skip over that, I guess have a very just brief description of the supply and demand, and then move on to some of the ongoing implementation issues and, I guess some of the questions that are being asked at the state level as we go forward. One of those is this reliance on market forces, that open SREC market, versus more bankable mechanisms, like long-term contracts or other ways to provide a little bit more price certainty. And there's also, a certain amount of debate about the role of different sectors, whether that be residential and commercial behind-the-meter systems or utility-scale systems. And ultimately, both of those kind of feed into this concept of balancing costs and ratepayer impacts with ratepayer benefits. Because, on one hand, you can look at a long-term contract that comes in below the current market price of SRECs and say, well, that's savings for the ratepayers. But on the other hand, you don't necessarily know if 5 years down the road that long-term contract is going to be below the spot price or whether it's going to be substantially above that and ultimately appear as a greater cost to ratepayers. In terms of sectors, you're talking about, well, is utility scale cheaper? Yeah, potentially with the economies of scale, it could be. But you're also thinking about, well, are there benefits that behind-the-meter installations, at residential establishments, at commercial establishments, provide that utility scale doesn't? And ultimately, you're talking about, taking the ratepayers who are more or less funding this type of program and making sure that you're providing them with both opportunities to participate, as well as, to the extent you can, minimizing the cost to them for the aspects of that standard where they're not directly participating. So hopefully that's a pretty brief summary of RPS issues and supply-demand, and I guess I'm going to turn it back over to Kathy, and we'll move on to the next speaker now.
All right, Justin, thank you so much for all the great info. We appreciate it. And as you said, we will move on to our second speaker, CJ Colavito. CJ started his solar career as a volunteer for a nonprofit organization in Nicaragua, where he lived and worked with locals in a rural village to usefully apply solar technologies. Upon returning from a year there, CJ joined the Standard Solar team. There he designed and managed the engineering and construction of over 20 megawatts of PV at more than 60 different sites, primarily in the Mid-Atlantic region. Again, he is currently manager of the company's commercial engineering department. He's also a NABCEP certified PV installer and a certified renewable energy professional as noted by the Association of Energy Engineers. CJ earned his Bachelor of Science in Mechanical Engineering from Virginia Tech. So we're very happy to have him with us today. And CJ, you go ahead whenever you're ready.
Okay, thanks a lot, Kathy. So as you can see here in the title, we have I'm going to be focusing more on the technical aspects, kind of complementary to Justin's presentation. I'm going to focus on some of the issues that can oftentimes be overlooked when evaluating the viability of a PV system. The SRECs and the renewable portfolio standards, I think in general, are extremely complicated and require a lot of time and attention, which oftentimes leaves the technical considerations to be a little bit overlooked, and depending on how much you know about them, you might not even know what was left on the table by not understanding the technical standards available. So generally, just the types of standards and incentives that you see in all the different states, I consider to fall under three categories. Your financial, which I think most people are pretty aware of, the different rebates and grants, all the different tax incentives and structures available, and then of course the renewable portfolio standards, or SRECs. Then you get the legal entities or legal pieces, which primarily are focusing on solar access easements and rights laws, just making sure someone doesn't throw a building in front of your PV system 10 years down the road and then blocks all of your available sunlight, which is a pretty big bummer. And then you have the technical areas, which is where I'm going to focus. The technical is really your interconnection standards, net metering, and then the aggregate or virtual metering. So first I'm going to discuss a little bit about the interconnection standards. And what I'm going to talk about is really how do the standards affect the way you can develop your project, and what types of things should you be looking for. So first question you want to ask is this customer utility, government, nonprofit, or some other entity, and how does that affect your project? For example, if this is a utility scale development project, the interconnection standards may be somewhat irrelevant, because if you're interconnecting with a utility behind the fence, generally most utilities have to comply, most systems have to comply with what the local authority having jurisdiction requires or what the local or state government requires, but generally they always defer to the utility in whatever they demand or need above and beyond, or even apart from what the normal standards are. You could do. A good example of that is most inverters, if not all of them, are required to comply with the UL 1741. Specifically in that standard, it says that the inverters can't affect the voltage or control voltage where it's feeding in power. But we're seeing more and more often, a lot of times even in the Mid-Atlantic region, utilities requiring the inverters to have power factor control and active power factor control to avoid voltage flicker, frequency changes, and even voltage drop or rise on the distribution lines. So it's really important to know who your customer is. Another thing is there even an interconnection standard? Some states don't have standards or specific policies, and depending on the state, that could be a good thing or a bad thing. Many times if they don't have a standard at all, it really means it hasn't been considered or looked at, and it generally means that there's not much PV development in that state. And then you want to really consider what the limitations are. Are there limitations on the system size, acceptable methods of interconnection, how the system can be interconnected, and other things very similar to that. One thing you want to know is what is the utility allowed to do and not allowed to do. Sorry, I went forward too quickly there. Some utilities in some states are allowed to charge all sorts of fees for having a PV system connected to their grid. For example, Virginia Dominion Power released a new fee at the end of last year that essentially amounts to $4 per kW. for system size for any system that's connected to a residential tariff that's over 10 kilowatts. And charges like that can sometimes render a project not financeable or not really viable from an economic standpoint. In most places, the utility is required to pay for the replacement of the existing meter for a bidirectional or net meter. So these are just things to be aware of and understand what's going on with different interconnection standards. So the next slide, which you just got a preview of, is interconnection policies that are in force in the states throughout the U.S. As you can see, I stole this from the desireusa.org website. Thanks a lot, Justin. And they have a lot of really great information up there. I'm going to reiterate this at the end of the presentation, but really, if you want to go to one place to find a lot of really good information quickly, the Desire USA website is a great place to go, and they have links to all the specific codes and standards from the different states, and it's really a great source for research and educating yourself on the specific markets that you're working in. As you can see here, there's 43 states plus DC and Puerto Rico that have standards, and you can see there's a handful that don't. So just really important to understand that just from a basic standpoint. Sorry, I'm waiting for this to respond here. Okay, so for net metering, I think this is a really important piece to consider is in a net meter system, how do the different rules by state or by utility really affect the way you can develop a PV system? It's really important to understand that depending on the tariff or the type of load that you're trying to interconnect your PV system behind, you have different standards. Many states have a different standard for residential, for commercial. Maximum system sizes vary, and amount of generation allowed varies. The way that it's metered, the value you get for the electricity exported, or your net excess generation varies based on whether it's residential, commercial, or even just based on size. So it's really important to understand that. Right hand in hand with net metering goes what the customer's tariff is. I've seen time and again where you may know your solar, you may know net metering, you may have put in a lot of systems, but every customer is a little bit different, and depending on what utility they're on and what their rate tariff is, that has a big impact on the technical viability and financial viability of a project to understand what they're being charged for or not being charged for. Do they have power factor fees, or do they have minimum purchase requirements from their electricity supplier? So if you install the PV system that offset 90% of their energy, are they really going to see that value? And as I mentioned, how you handle excess generation, some net metering policies allow full rate contribution to your net excess generation, meaning that they'll give you credit for both your transmission, distribution, and your generation, where some other utilities or states will only allow you to get credit for your generation and not your T&D while you're working on when you're exporting energy. So it's really important to understand all these things when you're looking at how to maximize your PV system. If you're getting full value for retail rate for excess generation, it may be smart to oversize your PV system if that's allowed, if you're allowed to exceed system sizes greater than 100% of your demand. So a case study I just wanted to go over regarding net metering and how the rules can really affect the way you design a system. An excellent example is Washington, D.C. In Washington, D.C., Standard Solar developed a project for the Catholic University of America back in 2009, and it was really one of the largest, if not the largest system in the District of Columbia that we were implementing at the time. And one thing that we weren't aware of at first was that they have a little bit different net metering laws than all the surrounding states, meaning Delaware, Maryland, and Virginia. And they actually have a cap on the total allowed PV system size for net metering at 1 megawatt. Many other states are at 2 megawatts or even larger, especially for commercial sites. The interesting thing about this application is we were building PV systems on 4 separate buildings The total system size was going to be about 300 kW DC, and all of the buildings were actually on one single master meter for the whole campus. So you had to really understand how the campus electric system worked and know that they had a master meter and that all buildings with solar within that entire campus were going to count towards that 1 megawatt cap. So it was really important to evaluate that. And as we've worked farther with this partner and we've added more PV to a couple of these buildings and other sites, we're trying to be wary of the fact that there's a 1 megawatt cap. Another really important distinction in their net metering program was if you're 100 kW or less, the customer gets credit for their net excess generation at the full retail rate, which means they didn't just give them generation credit, but also transmission distribution, also known as delivery, which oftentimes is about a third of the total electricity rate in the rates that are charged per kilowatt hour. For systems over 100 kilowatt, they don't give you credit for your net excess generation on the T&D or delivery rate, only for your generation. So that's an important distinction to make. In this case, we were able to go well over 100 kW, and it didn't really affect us because the total load on the campus was far greater than the amount of PV we installed. The total PV in this case was only going to offset about 0.25% of the total energy demand of the campus. So in this case, we didn't have to really worry about net excess generation because it's primarily an offset load condition. It's just something important to understand as we develop in situations like this, specifically in Washington, D.C. So virtual net metering, which is actually one of the more complex interconnection standards here, is in many states it varies greatly from state to state depending on what it is. Everybody defines virtual or aggregate net metering in different ways. They use different terms for virtual or aggregate net metering, and they mean pretty significantly different things. Sorry about that. So first thing to understand is how is the program structured, who's eligible to participate, is it anybody who wants to participate or only governments and nonprofits, and what markets or opportunities are available. And then primarily what you want to understand with these different standards is how can you use the standard to your advantage? What can you do in order to make this reduce the cost of implementing your PV system, and how is this going to be advantageous? Clearly, in states that didn't have net metering laws or virtual or aggregate net metering laws to begin with, it was very difficult to implement PV projects and make them financially viable, because without net metering, it's very difficult to get take full advantage of all the energy generated by the PV system, since oftentimes the energy at a specific site may not sync with the load, because of, the energy for a PV system is directly proportional to the amount of sunlight it gets. So an interesting case study that I wanted to go over for virtual net metering is to first think about the differences in programs to kind of illustrate my point. Is, for example, in Maryland, they have a brand new aggregate metering pilot program that started in November. It's pretty exclusive to only nonprofit agricultural municipal governments that can participate. So it can't just be a regular residential homeowner. It can't be a commercial customer. It really needs to be a municipal government, which generally includes schools and municipalities, wastewater treatment facilities, whatever the government owns, and then of course nonprofits. It's a maximum of 6 meters for the pilot program, and all meters must be within a single electric distribution company's territory, which is pretty standard. Obviously, it would be pretty complicated if you had meters throughout the entire state or multiple states that were in different EDC territories. And the PV system, which is a little bit unique for Maryland, is that you can size it to generate up to 200% of the annual aggregate baseline load. So the total energy demand of all the sites can be offset with the PV system design here. And then the allocation of energy is one that really varies greatly from state to state and policy to policy, which really is affected by the whether they want to divide the total energy out by the total number of meters equally, or is it a waterfall method where you prioritize the different meters that you're trying to aggregate, and meter 1 gets all the energy until there's excess and overflows down. So it's a pretty interesting program, and it's only a few months old, but Standard Solar has really embraced this program, and we see it as an opportunity. And we already have 4 megawatts worth of projects that are contracted, and we have interconnections approved, and the program's only been enforced for 2 months. Part of that's because we've been involved in the policy making, and we've been aware of what's going on. I'm actually a member of the Maryland Aggregate Net Metering working group at the Public Service Commission, so we're able to really get involved and develop projects in anticipation of the program getting passed. In Pennsylvania, they have a program that has some similarities, but also some significant differences. Their program started several years ago, and primarily about the same time as their net metering program was accepted, which was a little bit progressive of them and somewhat unusual for a lot of other states where aggregate metering or virtual net metering comes in later. All the meters in this case, they have to be within 2-mile radius of the PV system or the customer generator owned leased property. And there's no limit on the number of meters, which is interesting. Of course, they have to be in the same EDC territory as I stated earlier, which is a pretty common requirement. But what's interesting here is that this really more favors agricultural type applications, where in the Maryland program there's no limit on the distance from the array to the meters, so municipalities and schools can really take advantage of it because you could have an entire county's worth of schools taking energy from a large centralized PV system where the county may have land, which often is the case at wastewater treatment facilities or other government-owned lands. But in the Pennsylvania case, it has to be within a 2-mile radius, so it really needs to be loads that are essentially surrounding the PV system. And depending on the type of requirements, it can really affect the way projects are developed and how utilized the program really is. In this case, the Pennsylvania program, I've heard, hasn't really had widespread acceptance. There are a few projects developed, but it's not like a highly utilized advantage, where Maryland we see a really big advantage to the new aggregate net metering program, and we expect to develop many megawatts worth of projects over the next few years using this new policy. So a quick case study I wanted to go through to try and illustrate some of the advantages and things considered for virtual net metering is in a project with Perdue Chicken. We did a project for Perdue in Delaware in the Bridgeville area, and they had an agricultural products processing facility on one side of railroad tracks, and they had this beautiful flat open piece of land on the other side of some railroad tracks that they wanted to site PV. But their customer meter, as you can see here in the diagram, was located on the same side as their facility. Meanwhile, the PV is located on the other side of the tracks. And as you can see here, the red lines represent the tracks. This orange line represents a 25 kV power line. So in this case, we originally were planning to have to go underneath or over the railroad tracks in order to net meter at their transformer. But we found that that was going to be extremely complicated, challenging to permit, and clearly very expensive to meet the railroad company's requirements. And it was really at the beginning when Delaware released their virtual metering program, and we decided to go with the virtual metering concept as based on a recommendation of one of our subcontractors who is an experienced installer in the Delaware area. And we worked with some of our contacts, and we got it approved through the utility company to really have a PV system directly connected to the 25 kV distribution line, which really ran next to the railroad tracks on our side. So in this case, it was tremendously advantageous. And this is just really one example. Other examples where you can use virtual or aggregate net metering to your advantage are when the distance from the array to the load could be very long, even though it's on a contiguous property. Maybe it's a shorter distance to get to the distribution grid. Or perhaps between the array and the meter where you would want to connect to the load side of, there could be a forest or protected lands or wetlands or something. So it really can be an advantage, not just from thinking of using a large centralized PV system to get economies of scale and reduce costs to serve loads, several loads at different locations, but also to evaluate ways to get around obstacles and to lower costs on even a single PV system with a single load. In this case, we weren't originally planning to do aggregate net metering or virtual net metering because the agricultural products processing facility was going to consume, the PV system was really only going to provide about 20% of the processing facility's total energy demand in a year. So there was no need to aggregate other meters with it. But in this case, of course, it was really advantageous because of the obstacles between the PV array and the actual load. So I just have some final remarks. This picture here on the right is actually a finished photo of the PV system. You can see the railroad tracks here at the bottom and the 25 kV distribution line in front here. So just my closing remarks, if you take anything away from the presentation, is keep in mind, obviously, all the policies can be complicated and important, but don't overlook the technical considerations of PV system interconnections and net metering standards. Even if it doesn't make or break your project, it can make a big difference on the financeability of the project. It can help you to find new creative ways to implement PV and make projects happen that wouldn't have happened otherwise. I highly recommend to be very familiar with the rules and policies for the markets where you develop projects. Consider the impact early in development, not later after you have signed contracts and an engineer is tasked to figure out how to make it work. And I can't stress enough, the Desire USA website is a really great resource. I recommend everybody go to it if you haven't been there before. And use the rules to your advantage. I really like to think outside the box, push the envelope, find new ways to implement PV and reduce cost. It doesn't just help yourself, but it really helps the whole industry by setting precedents in markets on what can and should be done in order to implement PV more cost effectively and more widespread. And then lastly, a suggestion that has really paid dividends for me at Standard Solar is to get involved with the Public Service Commission or Public Utility Commission in your key project development areas. Knowing what's going on, what policies are being discussed, get involved in the working groups. It's a really great way to be on the cutting edge of what's being developed and also have a pretty significant opportunity to influence how legislation is interpreted. In many states, the Public Service Commission or Public Utilities Commission have a pretty significant amount of power to interpret laws and policies in ways that they see fit. And in some states, the commissioners on the PUCs or PSCs can be pretty favorable towards renewable energy because generally they're there to regulate utilities and defend customers who otherwise wouldn't necessarily have a voice. So being a project developer and offering some expert opinion and advice to teach these commissions how to grow the markets and add jobs and help bring more cost-effective energy to the ratepayers is a really great thing. And that's all I have.
All right, CJ. Well, we thank you so much for that great presentation. And now I'm sure after all that information, the audience has a few questions. Just a reminder, you can enter your questions in the GoToMeeting panel on your right under the Questions tab, and we'd be glad to share those with our presenters. You can also contact the presenters with the information up on the screen there after the presentation as well. So we'll start off with Justin here. He's had a little break of talking. So Justin, we would like to know, what is the best state SREC that there is right now, and why would you say it's the best?
You know, I guess there are a few different ways to answer this type of question. If you're thinking about states that have these, I guess, open SREC type trading markets, but have been doing, I guess, unique and kind of innovative things in terms of long-term contracts, you see like Massachusetts definitely has a pretty good solar environment right now. Connecticut, although it doesn't have a solar carve-out, has some provisions for utilities making purchasing what they call ZRECs, or zero-emission RECs, through long-term contracts from customer generators. You know, in terms of some of these other states, you know, a lot of times, you know, New Jersey is highlighted. Some of Pennsylvania in the past has been highlighted as, you know, a very good opportunity to develop. But, you know, at this point, if you say look at the supply and the demand for SRECs within both of those two states, you know, things have changed fairly dramatically within the last couple of years, and both of those markets are, you know, potentially oversupplied for this year and potentially the next year, and even in some cases beyond that. Or I guess what would be considered kind of an open trading jurisdiction where there's a shortage of SRECs currently. I mean, if you can develop in the District of Columbia, you know, they changed their laws recently in such a way that's been, you know, very positive in terms of creating an additional SREC demand and then getting rid of a lot of projects from out of state that used to be participating and were kind of saturating the market with SRECs. Now, on the other hand, I mean, you can look at a state like Colorado, a state like Arizona. You know, those states have traditionally been, you know, pretty good environments for solar development, and, you know, you would still expect them to continue to be. And, you know, in those states you have these, in many cases, relatively standard kind of solar incentive programs. Of course, you know, at the same time, you're still, in some cases, bumping up against, you know, cost cap containment kind of things, and that's, you know, potentially the case both in New Mexico and in Arizona. But I guess in the eastern U.S., Massachusetts and Connecticut really kind of stand out currently. D.C. kind of stands out, you know, very recently. Colorado's still a pretty good state, and then, you know, in California, you can do a lot of things without even necessarily needing to rely on SRECs to get that additional revenue. So, you know, California is certainly a good state to look into too.
All right, and I believe this one is for CJ. Any thoughts on net metering based on residential flat rate versus time of use rates?
Well, generally time of use rates are a big advantage for PV because usually peak demand periods for electricity tend to sync with peak sunlight periods during the day. Clearly that can be dependent on the type of PV system design you have, whether it's east-facing or west-facing, and when you expect the primary portion of your generation to happen. And it really depends on how the time of use rate is structured. I've found in our experience that most residential applications do not have time of use rates available, that they're under a pretty standard residential tariff that may or may not be seasonal from summer and winter. So I would see it to be a little bit unusual to see time of use for residential, but if it is available and you're allowed to select it, generally that's an advantage, but it's highly dependent on the way the tariff is structured and then also the type of PV system design. Again, if it was primarily east-facing, you would probably expect more of your generation to favor the morning rather than the afternoon, and that may or may not sync with the peak times.
All right, thanks, CJ. This question can go to whoever would like to answer. Where would you find a sample power purchase agreement for a residential installation or white papers to show the economics involved with that?
See, you know, I know that an organization called SolarTech had been creating, I guess, standardized type forms, like templates, I guess, for residential power purchase agreements, and I think also for commercial power purchase agreements. Beyond that, I feel like I've heard things, but I can't put my finger on anything right this second.
All right, and let's see, Justin, we'll ask you this one. Along those lines, well, I'll ask you this. You said that you kind of breezed over supply and demand and implementation issues. Was there anything else you think that people should know about concerning that subject that you didn't really get to touch on in your presentation?
Well, you know, I guess I gave that kind of very basic overview, and in terms of really figuring out what that supply and demand balance is, as I mentioned, it's kind of difficult already, particularly in establishing what the pipeline is, and if you can establish a pipeline, what the scrub rate is going to be. If you can look and see that there are, I don't know, 700 megawatts of projects in the queue, you know that not necessarily all those projects are going to be built. And it can be, very difficult to actually figure out, what percentage of those are actually going to be built with kind of changing market conditions. Another question that I didn't quite get to is, well, how do you relate supply and demand to actual SREC prices? So, when you think about what a solar alternative compliance payment represents, in many cases, in many states, it represents kind of a ceiling on SREC prices, in that, that's the fee that a load-serving entity would have to pay if, in fact, they can't secure enough SRECs to meet their obligation. But that really only applies in a case where the market is short. And when the market is short, you would expect prices to approach that SACP. When the market's long, it's a little bit of a different scenario. And when the market's wrong, when when there's more SRECs than are needed to fulfill the standard, theoretically the SREC price could drop to close to zero. In cases where you're not able to sell your SRECs at any price because everybody basically has what they need. But then that's where the multiple year lifetime of SRECs might come in, because if you think about it, and this is a presentation that's come through Bloomberg New Energy Finance, and the way that they think about SREC pricing going forward is that the value of an SREC isn't necessarily its value in any specific year. It's its value in any year when it can be used in an environment where there's a shortage. And so, basically what they've done is say, well, if I know that my SREC has a 3-year lifetime in New Jersey, for instance, and I recognize that the market is long this year, so my SREC has 0 value, and it's potentially long next year, so my SREC has 0 value. But 2 years down the road, there's the market is expected to be short or has the potential to be short. And I would, basically multiply the chance that the market will be short 2 years down the road by the solar alternative compliance payment, and say, well, that's the value of my SREC, because that's really the value that a load-serving entity would get if it purchased it today. It could use it this year, might not need to. Could use it next year, might not need to. But then they may have a greater demand in the 3rd year, and say would be willing to purchase it at a price above 0 this year in order to use it 2 years down the road.
All right, thanks, Justin. And then CJ, someone would like to know, you mentioned that virtual metering can be really useful for getting around obstacles such as railroads or long distances or wetlands. Could you do it around a large body of water?
I would imagine that it really depends on where the PV system is relative to where an available point of interconnection with the grid is. So primarily that requires you to know where the power lines are running and what voltage they are, and is it an available interconnection point, and where is the customer's electric service, or where is the load with that meter measuring that customer's demand relative to your body of water. But I wouldn't imagine you'd want to go through the body of water, but going around it or avoiding it would make a lot of sense. Wetlands is kind of similar to that it's a very wet and marshy area, and we've done that in a couple cases where we've basically gone the opposite direction of the customer load, where there's customer load on, say, the west, a PV system in the middle, and then to the east is the overhead distribution lines, and we've done that in a couple applications. So I guess it's hard to say without knowing exactly how the project's worked out, but my point was really to just consider it and keep it as an open option.
All right, and I think this is for you too, CJ. Someone said here in Southwest Ohio, there's relatively cheap purchased electricity, but this person hasn't seen any residential systems or small commercial projects that show a benefit or net present value. So do you have any successful projects in your portfolio that you can kind of discuss along those lines?
Actually, there's been some development in Ohio for municipal utilities to actually purchase would be officially utility scale solar owned and developed by a utility company. One of the problems that we encountered in development was really the SREC market. There's a point in time where the utilities went to the commission and they took advantage of a provision where the commission said, listen, if there's not enough PV development in the state to satisfy the renewable portfolio standard for that year, we're going to grant you a force majeure clause, and then you don't have to buy any RECs, or we'll, take down the amount of RECs that you would be responsible for. And the utility successfully got essentially reprieve that year, and it kind of sent the market into a tailspin because there was uncertainty from investors and other developers as to whether the commission was ever going to hold their feet to the fire and make the utilities purchase the SRECs. That has since changed, and there was a procurement process in Ohio. I believe it was in October, and Justin may be more familiar with this than I am. And there are a number of projects, pretty large-scale projects being developed in Ohio. I don't think I'm at liberty to discuss exactly which ones there are, but I do recall there were press releases on one in Bryan, Ohio. I believe it was a couple megawatt size utility scale project for a municipal utility there. There's another one in Napoleon, Ohio. But there are others even larger that are in development. So unfortunately in Ohio, the REC market has really played a big role in whether or not projects get built and how they're developed. And as far as I understand, there's no scheduled procurement process for additional RECs at this point in time. So there's a lot of uncertainty from developers on whether they want to invest the resources to develop and basically have a project ready to apply for the next procurement process, or if they want to abandon Ohio altogether until they have more certainty and go develop in other markets.
All right, well, I think that's about all we have time for today. If you do have other questions, remember you can always email or give our presenters a call. But at this time, I would like to thank both of our presenters, CJ and Justin, for being here to share their expertise with us. I think we all learned a lot. And also thanks to everyone in our audience for listening. Again, the presentation, the entire webinar will be emailed to all attendees and registrants at the end of this. And then I hope that you enjoyed the presentation. And Solar Power World will be doing webinars bi-monthly, so keep an eye out for more to come. Thanks again, everybody.